Well, I can officially say good afternoon to everybody on the East Coast, and it's still a good morning to everybody from Ohio West or from Illinois West. There we go. Greetings and welcome to another Takeo Tuesday. Glad to have you with us. My name's John Barba, and I'll be talking with you today about one of my favorite topics, the design for residential domestic hot water recirculation. So I'm really looking forward to it. I think it'll be a good time, and hopefully we'll be able to share with you some information that can help you as you prepare to design and install domestic hot water recirculation in residential applications, because it is most definitely a growing trend and a growing business, and one that if you don't do it correctly can come back and bite you in the hindquarters if you're not careful. And we'll show you how that can be a problem. Just before we get started, I just want to, every time we do this, I want to make sure everybody understands how this all works. This is a webinar. This is me talking and you listening, not the most interactive of forums. What makes it for the viewer that we have learned over the last several years is I would request that you just treat this like we were in a classroom together. That means grab a pen, grab a pad of paper, and take notes as we go. Yes, this is being recorded. Yes, you'll be sent a link to the recording tomorrow, 24 hours from now, so you can watch that recording as many times as you wish. But it's important to take notes as we go. That helps you keep engaged. It doesn't take away from your attention. It actually does help heighten your levels of attention, and that way you'll also have a written record of what went on. Also, the other part to make this as interactive as possible will be to ask as many questions as you can, as you see fit. I love questions because it makes me, for several reasons. Number one, it makes me it helps me stay on top of things and helps me keep in tune with what your needs are. But also it makes sure that I haven't lost my internet connection. So if you could make sure that you type out your questions as they occur to you. We'll take every few slides, we'll take a break and go over some of them. Just to make sure everybody knows how to ask questions, on your control panel, there is a little section marked chat/questions. And I see that James Zampano has already figured that one out. James, I think you've been a regular, so you know how to do this. But for everybody else on board, if you could do this for me, just go to that chat question section and type in good morning, good afternoon, how you doing, nice shirt, I like the office, whatever you got, whatever works for you. And that way I know that you know, hey, great, all these are popping up, awesome, terrific, thank you folks, really appreciate it. Good. Now, and any questions is fair game, so please ask them as they occur to you, and as I said, we'll try to get to those as we can. You will also find a handout section on your control panel, and there are 3 handouts that you can download that will help you out. A couple of charts for velocities for different types of pipe, and one is just a Word document that has a link to something I'm going to show you in a little bit. So download those at your leisure. And one last thing before we get started, I just want to conduct a quick poll that has to do with our topic today. So I'm going to launch this poll, and you will be able to, let's see, I got to select a poll here. Do I have a poll? Manage polls. Yes, that's the one. Okay, let me launch this poll. All right. I believe that's come up to you. Let me know if it has. It's a poll on what is the purpose of domestic hot water recirculation. So just pick your responses. Let me know if you can see it first and foremost. Type that in if you would, and that way I know that we have it. And let's see what we got. Okay, great. Everybody is jumping in. So please put in your answers, and we'll do this for about a minute or so. I just want to make sure where we are in the answering process. Okay, very good. This is interesting. I can see the the answers coming up, and it's kind of cool to watch. Very good, very cool. You got to be on my end to see it. It's pretty neat. All right. Terrific. All right, I'll give you another 10, 15 seconds. So just read them all and see which one makes the most sense to you. Okay, terrific. Let's close the poll. And actually, before we do that, I just want to go over, I just want to give you guys a round of applause. 41% of you chose none of the above, and that is the correct answer. Okay, that is the correct answer. Of the of those supplied to you, none of the above are the purpose of domestic hot water recirculation. So it is not to speed up hot water delivery by boosting pressure. That's not the purpose of domestic hot water recirculation. And it is not to ensure adequate flow to hot water fixtures. That's the system pressure. That's got nothing to do with recirculation. To ensure adequate water pressure to all fixtures, good on you. Nobody picked that one. It was nip and tuck there for a while. We had 38% of you picking all of the above, but 43% of you picked none of the above. So that's terrific. I appreciate that. That's good. That's good work on your part. But let's explain why it is none of the above and why sizing is so important. So excellent. Good work, folks. Good work. So I want to make sure we're back to our screen. Everybody, just somebody chime in. I want to make sure every time I've launched a poll, sometimes I lose the screen. Can you see my? Can you see the Takeo Tuesday sign? Just let me go on that one there. Okay, very good. Okay, so let's talk about domestic hot water recirculation. And does domestic hot water recirculation pump sizing matter? Does it matter what size pump you put on there? Well, what do you think? We got Gary says yes, very good. Yeah, does it matter? I mean, don't we just have to put a pump on there and let the water run and never control it? Just let it run all the time. That way, whenever anybody turns on a faucet, they have hot water right there. So shouldn't that just work, right? Shouldn't that just be fine? That's all we need to do. Well, I will suggest to you that sizing does matter, okay? So when you sit down and ponder that, like Rodin's The Thinker, understand that yes, sizing really does matter, and it's the critical element of domestic hot water recirculation. Why does it matter? Well, this is why it matters. Here we see a couple of pictures of copper piping with pinhole leaks. Sizing matters. If our sizing is too big, meaning we're pumping way more flow through the pipe than it wants, we're going to cause erosion from the inside out and leading to pinhole leaks. Now, understand this, pipe has but one purpose in life, and that's to keep the water on the inside until it reaches a fixture, right? In a plumbing system, that's its only job. Once we develop pinhole leaks, that pipe has failed. It's failed its job to do that. And by over pumping and sending water through the system at high velocities, we now contribute to the early demise of the pipe, as you see here. And it's not just copper, okay? It's not just copper. It can happen with PEX as well. So both the copper industry and the PEX industry have, and CPVC and other types of plastic pipe, all have velocity limitations for normal usage flow, as well as domestic hot water recirculation flow. So we really want to be cognizant of that. And when we size our circulator, that's kind of the speed limit we're talking about for the recirc pump. It's the velocity and the GPM limit that the copper pipe industry and the PEX pipe industry and the plastic pipe industry put on their pipe for domestic hot water recirculation purposes. That's the speed limit that we have to be cognizant of, and that's the speed limit we have to design to. So excellent. Again, why is this happening? Why do these things happen? One of the things, I guess basically the pipe is trying to tell us something. And I found this online the other day, and I love this quote because it's so true. When you replace why is this thing happening to me with what is this thing trying to teach me, everything shifts, right? We have pinhole leaks in copper pipe on our recirc line. What is this trying to teach me? It's teaching me that the pipe has its limits, and we have to respect those limits, and we have to design around those limits. So whenever you are looking at doing domestic hot water recirculation, job one is to find out what the limit is. Job two is to not exceed it, because the last thing we want to do is turn our domestic hot water system into a sprinkler system. That would be a fundamental failure. So understand what the pipe is trying to tell us. It's telling us there's a speed limit that we have to respect, and we have to make sure the pump doesn't exceed that. So those are the important things to remember, important takeaways. Now, let's talk about the four elements. Velocity is an element in creating pinhole leaks, but there are three others. Let's take a look. Well, the first one is elevated water temperature. Okay, the higher the water temperature, that becomes an element in developing pinhole leaks. So if we're talking around 140 degrees, maybe above, an element to domestic hot water. That's an element to creating pinhole leaks. Now, it's not something we can really mess with because sometimes we have to make water up to 140 degrees to take care of Legionella and things like that. So it's not something that we can really impact. All right, that's not something we can really impact. But there are three others. Let's see what we have here. Well, velocities. We talked about velocities over 2, maybe 3 feet per second. Now, that's something we can control with our recirculation pump by sizing the recirculation pump properly. So let's keep that one off to this side. Velocities, hot water at high velocity, that can create a problem. We can deal with the high velocity. We have the ability to deal with that. Chlorines, chloramines, other ooky stuff in the water. Well, yeah, chlorinated water is most definitely a factor in causing pinhole leaks in copper. Now, we can't really impact that, can we? That comes from the utility. That's the people that send us the water chlorinate the water to help keep it clean and disinfected. So we can't really impact that. So of the three so far, elevated water temperatures, we really can't. High velocities, yeah, we can. Chlorines, chloramines, things like that, we really can't. The last element is also something that we can control, and that is continuous circulation. Continuous circulation is a key element in domestic hot water, is a key element in creating pinhole leaks. Now, if we think about this, hot chlorinated water at high velocities running continuously, that, folks, is a recipe for disaster when it comes to your piping system. That will cause pinhole leaks in copper piping and it'll help deteriorate PEX piping very, very quickly. Hot chlorinated water at high velocities running continuously is the kryptonite for any piping material. All right. We can't really deal with the high temperature. We can't really deal with chlorine, but we can deal with velocities. All right. We can make sure we size that circulator properly. And by intelligently controlling the system, something Dave Holdorf talked about 2 weeks ago, by intelligently controlling the system and not having it run continuously, we can control that. So we can impact 2 of these 4 elements to protect the plumbing system. And that's really what we're talking about, is protecting pipes. So we design around appropriate velocities, and we design around an intelligent control strategy that does not have the pump running continuously. Now, here's the thing. Having the pump running continuously is wicked easy, right? That's the easiest control strategy there is. You plug it in, you get the heck out of the way. Hey, I've solved a bunch of problems. Number one, I don't have to pay for it. I don't have to buy any kind of a control strategy or do anything for my control strategy. That's number one. Number two is any time of day or night, 24/7, if anybody opens up a hot water faucet, they're going to have hot water, right? So that solves a problem, and it meets a customer expectation. So we have to think about, how do we deal with controlling our circulator, and most importantly, how do we deal with sizing our circulator? And that's what I want to focus on today. Excellent, excellent, excellent. So just to kind of recap, what is a domestic hot water recirculation pump supposed to do? And the reason I had this poll is I probably had I'm going to say a half an hour discussion / disagreement, almost argument with an engineer on this very topic. He wanted to size the circulator to ensure a proper flow rate. The domestic hot water recirculation pump, he said, that had to be designed and sized to provide adequate flow to all of the plumbing fixtures in the structure. And I said, no, that's not what it's supposed to do. It's really not supposed to do that. The water pressure in the house is doing that. That's how you get adequate flow, by proper pipe sizing and proper pressure. He says, no, you put that pump on there, it's got to be sized to make sure I get adequate flow to every single fixture. And I said, well, let me ask you this. If you didn't install the circulator at all, meaning there was no domestic hot water recirculation pump, would you get adequate flow to all the fixtures? And he said, yeah. So I just sat there and looked at him and waited for him to figure it out. And it took a little longer than I thought it would. It took maybe a couple of minutes. I just sat there looking at him, didn't say a word, waiting for him to kind of figure out that, yeah, wait a minute. If I don't put this pump in, I'm going to have adequate flow. Why is the pump going to change that? You know, the pump's not going to make it better, right? So no, it's not to deliver hot water to the fixture. The goal of a domestic hot water recirculation pump is to keep that hot water line primed. Keep it primed with hot water so that when someone turns on a fixture, we minimize the wait for hot water at that fixture. Think about it as not moving gallons, think about it as moving heat. All right, it's a great way to consider domestic hot water recirculation. I just want to make sure that when I turn on that faucet, my wait for hot water is minimal. And the pump will do that by simply keeping the hot water line primed. That's really its only job. Its only job. And for that, we have to watch the maximum velocities. All right, so I want to check with you guys. Any questions, any thoughts as we continue? Okay, what kind of engineer was he? Says Michael House. Answer, a bad one. Well, no. It was a new concept for him. That's all. It was a new concept. He hadn't really dealt with domestic hot water recirculation, so he kind of got it confused with with a booster pump. So it's understandable. It is understandable. Alrighty, good. Let's continue. Here's some, this comes from the Copper Tube Handbook, published by the Copper Development Association, which again it's kind of the copper, it's the guidebook for the copper industry. And they give us some information on water velocity limitations that, again, we have to understand and respect. First is, it says over here, the designer should not exceed flow velocities of 8 feet per second for cold water and 5 feet per second for hot water, up to approximately 140 degrees. In systems where water temperatures routinely exceed 140 degrees, lower flow velocities, such as 2 to 3 feet per second, should not be exceeded. And now this is your hot water delivery, your cold and hot water delivery. This is your fixture stuff, okay? Your supply piping that you would have to respect if you did not put in any domestic hot water recirculation at all. All right, so those are your overall 8 feet per second, 5 feet per second velocity limitations. Additionally, it says locally aggressive water conditions can combine with these two considerations to cause erosion corrosion if system velocities are too high. All right, so they're telling us, they're outlining in the handbook that aggressive water, chlorinated water, etc., can combine with other considerations to cause erosion and corrosion from the inside. And lastly, this last paragraph, due to constant circulation and elevated water temperatures, particular attention should be paid to water velocities in circulating hot water systems. Right, that's important. That is important. Both the supply and return piping should be sized so that the maximum velocity does not exceed the above recommendation. So they're telling us in plain English, watch it. Okay, watch your velocities. Okay, and what are those velocities? Excuse me, let's put this back here. Care should be taken to ensure that the circulating pump is not oversized and that the return piping is not undersized. Both are common occurrences in installed piping. Now remember, when we size, what is your typical domestic hot water recirc return line size? When you're installing a recirc system, what size do you usually install for that recirc line? Not the supply piping, but the recirc line. Type in your answers. Just let me know what you're thinking. What size is that pipe? All right, yeah, Travis, is 1/2 inch, sure. Most cases, it's 1/2 inch piping. Jesus says 3/4 inch. Daniel says 3/4 inch. Very good. Yeah, in most residential applications, we do see 1/2 inch, but 3/4 inch. I'm gonna make a case for 3/4 inch recirc lines that might be kind of compelling for you, right? So we got to make sure we don't undersize that. So we have to watch that the pump isn't oversized. And when you think about how we're setting this system up, it is truly amazing how small that circulator really does need to be. All right, and when we look at that, we understand that the circulator itself doesn't have to be that big, and we do ourselves a favor by making the return size pipe big enough. And hey, if we want to go to 3/4 inch, there's some benefits there. Now let's take a look at exactly what this means. This chart is in your handout section, so you can download that at your convenience. But what it's doing is it's telling us two types of copper pipe, type M and type L, and it gives us the GPM maximum flow per pipe size. And it breaks it down into recirc, into hot water, and into cold water piping. So if we take a look just at the recirc section, all right, just at the recirc portion of our piping system, and we look at 1/2 inch pipe, if we look at the 2 feet per second guideline, because I'm by nature a conservative person, I don't want to necessarily push the envelope unless I have to. I'm looking at a maximum flow rate for the recirc portion of 1.6 GPM. Now think about that. That's 1.6 gallons per minute flow rate. So when I size my circulator, when I size my recirc pump, I'm looking at a maximum of 1.6 gallons per minute. Let that sink in, 1.6 GPM if my recirc line is half inch. Now, again, that's not when I turn on the faucet, I'm only getting 1.6 gallons per minute out of there. That's not what it's saying. It's saying that the flow through the recirc portion of that pipe should not exceed 1.6 gallons per minute. And it's a maximum, not a target. All right. Now, if I bump that up to 3/4 inch, now I have a little bit more leeway. Now I'm looking at 3.2 GPM. Gives me a little bit more leeway to play with. So there's an instant, if it's a really long line, let's see that, maybe that 3/4 inch pipe might not be a bad idea. Okay, it might not be a bad idea. And again, just have to point out, I want to say it again, this is the recirc flow, not the system flow. The system flow through the piping is going to be what you need to, what the fixtures need. Okay, the fixtures are going to get the flow they need. I'm just talking about the section of pipe from that farthest fixture back to the mechanical room if we do have a dedicated return line. All right. I want to make sure that makes sense. So let me give you a little feedback on your side, folks. Just type it. Does that make sense? Do we get why that is and what we're trying to say? It's not the fixture. We're not limiting fixture flow. It's flow through the recirc portion of that pipe. All right. Very good. Travis, Carrie, excellent. Great. Terrific. Now, PEX is a little bit different, okay? For PEX, the domestic cold water piping, we actually have a maximum of 12 feet per second, but a recommended velocity of 10 feet per second. So they give you what they recommend, and then they throw the max back at you a little bit. On the hot water side, again, max of 12, but the recommended velocity is 8 feet per second. And it does have a maximum operating temperature about 200 degrees Fahrenheit. Now, specifically, they will give you domestic hot water return piping guidelines. Now we're talking a maximum of 2 feet per second. So we go way back down with PEX piping, regardless of size. It's a maximum of 2 feet per second with a max temperature of 140. Okay, and they give you the sizing recommendations that you can find in the ASPE engineering guide, volume 2 for plumbing systems. So with PEX, we're dealing with 2 feet per second max. All right, 2 feet per second max. So that's again good guidelines to follow. We got a question from Jesus. What if the water temperature in the loop is designed to be 110 degrees or 90 degrees? Does that theoretically allow for higher velocities? Theoretically, probably, yeah. But again, these are the things you just don't want to necessarily tempt fate. Again, for me, I would design around a max of 1.6 if it's a half-inch pipe, 3.2 if it's 3/4. Those are just good design guidelines where you don't have to explain yourself if something goes wrong. That's always the approach that I take. So let me know if that answered your question, Jesus. Very good. All right. So again, our velocities, 2 feet per second with domestic hot water, and that's a maximum of 140, up to 140. All right, very good. Now, again, here's the chart that we're looking at here for our piping, and they say a max of 2 feet per second, but then they give us some proper flow rates that we really want to be, for velocities, we want to be looking at our, oops, I'm sorry, hello, go back one. There we go. Like for half-inch pipe, now for half-inch pipe, 1.1 gallons per minute. Now that's lower than the 1.6 for half-inch copper. Why is that? Well, the ID is smaller in half-inch PEX. So we're looking at 1.1 GPM for a maximum flow rate with half-inch PEX, 2.2 GPM maximum flow rate for 3/4 inch PEX on my return line. All right. So again, we have these limitations. We have the feet per second, we have the velocities, but our limitations are 1.1 GPM for half-inch, 2.2 GPM for 3/4. Okay. So very good. Now, what does this all mean? It just means keep calm and do the math. I'm sorry I spoiled that. I worked a long time on getting that reveal just right, and I jumped the gun a little bit, but I hope you appreciate it. Keep calm and do the math. do the math when it comes to sizing your domestic hot water recirculation system. And we give you a very easy to use tool to do that. Now, great question from Jesus. Does the difference between PEX A and PEX B have any significance? No, not. It's not differentiated in any of the manuals that I've seen. So PEX A, PEX B, PEX C, no difference whatsoever. Again, and again, any PEX manufacturer is going to tell you that hot chlorinated water at high velocities and continuous circulation is the kryptonite for PEX. We learned that firsthand when I worked at Uponor. That was a major no-no that was developed over time. So yeah, there's no difference for the type of PEX. It's PEX in general. Watch your guidelines. 1.1 GPM maximum flow rate for half-inch return, 2.2 maximum flow rate for 3/4 inch return line. So very good. Excellent question, Eric. All right. Now, when we are doing our design, okay, and this is for a dedicated return line, the math gets, the design is so much easier when we're talking about a crossover valve under a vanity, like the hot link valve. The math is so much easier, as we'll show you. But this, we just have to do a little bit more math to understand what's going on. But with a dedicated return line, here's the part: we don't care about flow rate through the supply. So all that piping all the way to that final fixture, couldn't care less. We don't care about the flow rate through that. That's the maximum design, okay? That's already been taken care of. The only part we do care about, excuse me, is this dedicated return line from, here we go. We got to get that right. I keep spoiling the reveals here. So the only part okay, try that again. Come on. I want the pen. There we go, right here. The only part we do care about is this portion right here, okay? That 130 feet of half-inch copper in this example. That's the part we care about. That's the part we want to keep at. If it's copper, 1.6 GPM. If it's PEX, 1.1 GPM. That's the only part we care about. The distribution piping, we have our maximum velocities for fixture delivery, and that's all pipe sizing. In terms of worrying about what that circulating pump will do, we care about the dedicated return line, and that's the only thing. So good. Now I want to show you that cool tool. All right, let us check out the really, really, really cool tool. All right, and I'm going to just dump out of this presentation real quick here and bring you here. All right, this is our Takeo website. Okay, and there you see the System M, that is our heat pump, but that's not what we're talking about today. We have a domestic hot water recirculation size right program on our website. And in fact, if you download our suite of apps from the App Store, you can get it on your phone as well. But I want to show you this on our website. So if you go to Selection Tools right up here at the top, okay, and way over here on the right, you have Domestic Hot Water Recirc Size Right Circulator Sizing. So let's click on that, and we'll get into our app that will help you size your domestic hot water recirculation pump. And this is where it gets kind of important. And this gives us the ability to quickly and simply figure out what circulator we need, and if it's a multi-speed circulator, what speed we should set it at. Okay, all good stuff, all good stuff. So let's take a look at, let's do our basic system. Is there an existing domestic hot water recirculation line installed? Yes. All right, water heater type. Let's just go with a tank type here for now. And then let's look at piping layout. What kind of a piping layout? Is it a trunk and branch with recirculation, or is it a full-size loop? Typical plumbing is trunk and branch. If you want to see a piping layout, you just click on that, and it'll give you an idea of what it's supposed to look like. So you get an idea of what you're dealing with, okay? So that's just a nice little addition, a nice little thing to help you in your design. Next, we go to our supply and return pipe material. So type M copper, for the supply and return. The reason it's different because it may be a retrofit and you may have refitted the return line with return line in PEX tubing. So you have that ability to tell it what's the supply piping material, what's the return piping material. I'm going to leave the return piping, both materials the same, type M copper. Next, we go with our piping calculations. All right, and we want to know the size of the pipe and the total linear feet. So it starts at the supply pipe, we start at the mechanical room. And what pipe do we have leaving the mechanical room? Well, let's say it is 1 inch. All right, and let's say I have 20 feet of 1 inch. Okay, hit tab, and that gives us 20 feet of 1 inch. What else? Well, let's have some 3/4 inch. And what we're doing is we're going all the way to that last fixture. All right, let's say there's 75 feet of 1/2 inch pipe or 3/4 inch pipe. And then lastly, we have 1/2 inch pipe. And let's say there's 30 feet of 1/2 inch pipe. So I've got 125 feet altogether of pipe, 20 feet of 1 inch, 75 feet of 3/4, 30 feet of 1/2 inch. Now we want to size the return line. Okay, so let's just pick 1/2 inch. And let's say it's 125 feet all the way back. All right, now you'll note right here what pops up. This line has a maximum flow limitation of 1.6 GPM. That's already been popped out for you. It's already there. All right, now we go down to our summary. So right now it's telling us, hey, your circulator is 1.6 gallons per minute. That's the max. Through our piping arrangement, we find that we have 10.7 feet ahead. If we go over to the right-hand side, we see the total volume, okay, the total volume of water in that pipe, 3.32 gallons per minute. And we see the pressure drop at 1.6 gallons a minute is a total of 7.5, just a little under 7.5 feet ahead. Now we add our valves and fittings. If there are valves and fittings in there, and you can adjust this up or down depending upon what you need. All right, you want not a lot of fittings, not a lot of valves and fittings. You can adjust it up, you can adjust it down, whatever you need. We have to take those into account. I'm going to leave it at 40%, and that gives us 2.99 GPM, or 2.99 additional feet ahead, for a total of 10.5 feet ahead. Now, do I have a mixing valve present? Well, yeah, I do have a mixing valve present. And what's the additional feet ahead from the mixing valve? Again, what you would do is look up the CV of that valve, the CV rating of that valve, figure out at 1.6 GPM, how many feet ahead do I have here? And then you would input that number. And in this case, it's 1.83. So right now it's telling me I'm going to need a circulator that does 1.6 GPM at 12.3 feet ahead. That's what I need. Now I can figure out what kind of circulator do I want. Circulator efficiency type, standard efficiency or high efficiency. Well, I'm going to pick standard, or I'm going to pick high efficiency. And connection type, flange, sweat, or union. It depends on where you are and what you use. Okay, I'm going to pick union. And once all that's done, I'm going to pick search. And here it's giving me a couple of choices. It's giving me either the 006E3 as just a circulator, or the Smart Plus E, which is a 006E3 plus the Smart Plug control. Now here's the important part here. If I were to click on the circulator itself, look what's popping up here. All right, it's giving me some basic information. All right, catalog, instruction sheet, submittal. I can click on all of those to get to where I need to be. I can go click here and go right to the product page on the website. But this is the important part right here. If I click on this, it's going to give me the pump performance curve. All right, it's going to give me the pump performance curve. And let me just shrink it a little bit so you can see it all. There you go. And it says right here, this is my operating point. All right, 1.6 GPM at a little over 12 feet ahead. Now, the 006E3 has a dial, kind of a smooth volume dial. The more I turn it up, okay, the more I turn it up, the faster it goes. So from the looks of this, I would set that dial at just a shade below the max setting. And now I would have my I would have my velocity. I would have the flow rate I need, the velocity I'm looking for, and effective recirculation. Now, if we go back, I want to go back here real quick. Let's do this. We notice 3.32 gallons of water, 3.32 gallons of volume in that system. If I click on show details, all right, that's where I get this number, okay? It's telling me how many gallons per feet in 1/2 inch, 3/4, and 1 inch pipe. Here's the total number of gallons, and it's 3.32. Don't particularly care how many gallons are in the return line. That doesn't make any difference. 3.32 gallons. If I'm running at 1.6 GPM and that pump turns on, I will have that line filled with hot water in a little over 2 minutes. All right. Now, here's the thing about our smart plug for the Smart Plus E. That'll run that circulator in a 5 minutes on, 10 minutes off pattern. So it's going to run the pump for 5 minutes and turn it off for 10, on for 5, off for 10. What that means is we don't have continuous circulation. We've taken that contributor off the table. I'm going to run for 5 minutes at 1.6 GPM. So as far as when that pump turns on, I've got this line completely primed and ready to go. If all of my hot water pipe is insulated, I'm going to have hot water in that line for that entire 15-minute period, or for the 13 minutes after we get that run primed. It's going to stay hot and speed up the delivery and make the delivery quick when I turn the faucet on. Then it's going to run for another 5 minutes to recharge the line, if you will. So this tells me I'm in really, really good shape. All right. Now, I have the ability to do a couple of things here. Remember, I said if I don't like running that pump that high, I can, for whatever reason, I can go down to, say, 1.2 gallons per minute if I wanted to, right? Now, if I wanted to do 1.2 gallons per minute, notice the head drops, right? Because the flow is less. If I wanted to set it up at 1.2 gallons a minute, I could. The net result is going to be here. All right, now I'm in the mid-range for my pump speed. Not that it matters much, but it just, if I was on the edge of being able to do it with a certain pump and wanted to get it into a different pump, or if I just wanted to run the pump at a slower speed in order to use a little bit less electricity, I have the ability to do that. Remember, 1.6 isn't a target; it's a limit. Okay, 1.6 GPM is a maximum. It's not a target. All right. Now that means, okay, the pump will probably have to run closer to 3 minutes to get that line fully charged. But again, I've got 5, so we're working okay. All right. Any questions do you have out there, folks? This is kind of interesting stuff. All right. This is interesting stuff. The tool does not allow for supply piping sizes above 1 inch. No, this is a residential tool, Jesus. So thank you for asking that. This is a residential tool, and we are working on a commercial version of this for larger systems, but right now we're just dealing with a residential tool. So it's kind of where we're at right now. They're going to be larger residential applications where maybe you need 1 1/4 inch pipe, and we can see about adding that if necessary. But at this point, we try to hit the big sweet spot of residential applications, and 1 inch was the max. Determine the percentage of valves and fittings in relationship to the designed piping system. Is it all valves and fittings in the system? Yes, it covers all. Remember that circulator has to overcome the entire pressure loss of the whole run from the time we leave the water heater till the time we come back. So yes, we include all of that. Now the percentage is kind of that's a kind of a guesstimate. All right. In hydronics, when we're talking about a closed loop hydronic system, we generally we use a multiplier of 1.5. We allow for 50%. All right, we allow for 50% of the total pipe run. We add that 50% to allow for valves and fittings and stuff that's in the way. Why do we do that? Well, an elbow has the same pressure drop as a certain amount of feet of pipe. For example, a 3/4 inch copper elbow has the same pressure drop as roughly 2.5 feet of straight copper pipe. A T has the same pressure drop as 5 feet of pipe. 45 has the same pressure drop as 1 foot of pipe, and so on and so on. A full port ball valve has the same pressure drop as 2.2 feet of pipe, etc. Now we can count them if we have that ability. We can actually count the valves and fittings, figure out the equivalent length, and put in a percentage that way. Quite frankly, Jesus, this is an estimate. All right, this is an estimate. All right, when we get to that point, it's some people like to estimate high, some people estimate low. Actually, I've seen people estimate really estimate in the 1.2 to 1.3 range, because if they know how the piping's installed, if there are a lot of fittings, you want to estimate high. If there are less fittings, you estimate low. It's not an exact science. It is, quite frankly, an estimate, and it's the best estimate that you can make. So I don't know if that answers your question, Jesus, but it's the best answer I have. Okay, but it is the entire line. Is there a danger of backflow at the final fixture if the pump draws too much flow? I'm not sure I understand the question. Would we, because meaning pulling cold water into the hot water line? Is that what you're talking about, Daniel? Please elaborate. Because again, okay, that's what you mean. I think very little, if any, because again, what we're doing is simply running the connection is all through just the hot water line. So I mean, would we be sucking cold water would be sucking cold water through a closed faucet, through that faucet into the cold water line and into the hot water line? It's not how a pump works. It's actually, take that back. It's not how a circulator works. A circulator is just creating a pressure differential to create flow through the line. If the fixture's closed, never going to happen. B, if the fixture was open, could it conceivably happen? I don't think so, because there's no pressure differential on that. We're not creating a pressure differential on that side of the cold water, on the cold water side, to suck flow through the faucet and into the cold water line, into the hot water line. I don't see that happening. I don't think that's possible. So good. Let me know if I answered your question. It's a good one. In a retrofit, what happens if it's too difficult to get to the last fixture? Well, then you won't have hot water recirculation at that last fixture, I guess, Carmen. That's a good question. If you can't get to that last fixture, if you have it at a fixture further up the line from that last fixture, you simply won't have domestic hot water recirculation at that last fixture. You'll have it at the last fixture you connect that line to. The water in that line from the point where we take the recirc line off to that last hot water fixture, that's going to just simply drop naturally. If I turn that faucet on, I'm going to have to evacuate that branch of the piping of cold or tepid water before the hot water gets there. So it's not optimal. It certainly isn't optimal. What it is it's the best you can do, right? So yeah, they're going to have to wait a little bit longer for domestic hot water than the other fixtures further up the line. But if that's what you can do, Carmine, that's what you can do, and that's managing expectations with your customer, letting them know ahead of time. One of the things Dave Holdorf taught me, and one of his best sayings is, a discussion beforehand is an explanation, a discussion afterwards is an excuse. So that's definitely something you would want to talk about ahead of time. Very good. Great question. All right, if the final fixture has a point of use mixing valve, will a larger pump suck cold water through the mixing valve? Again, I don't think it's going to happen, because it's not. If we have a mixing valve, we have mixing valves at the water heater. Remember, it's not a pump, it's a circulator. Pumps create pressure, and they move water, up, etc. A circulator, it's a small circulator. A circulator is simply going to circulate water through a valve. If that mixing valve is open, it's a thermostatic valve, right? It's going to open and close based on the water temperature. So whatever water comes through that mixing valve, because the gland inside has shrunk because we need the water's too hot. Well, yeah, you're going to get hot water moving into the system. As the water heats up, the gland is going to expand, close off the cold water line, and you're good to go. So again, I'm going to say I just can't see that happening, especially with a pump running at 1.6 gallons a minute. I mean, if you oversize, is it more flow? Yeah, but I don't think there's a pump you could put on that's going to do that. Again, it's a circulator. It's working on a pressure differential. It's not a pressure creator. It's a pressure differential machine. It's creating a pressure differential within its loop to create flow. So I can't see that happening, Jesus. But again, excellent question. All righty, let's see what else we have here. I want to answer a couple more questions, and I want to look at how we would use this with a crossover valve. So let me get a couple more questions here. Let's see. Charles asks, do we need a check valve or a balancing valve where the domestic hot water connects to the DHWR pipe? Check valves are generally used back at the circulator. All right, they're generally used at the circulator, not if that's what you mean. Yes. Okay. If I understand your question correctly, yeah, you will. A check valve will be useful here. Now the 006E3, because of its composite body, does not have room for an integral flow check, so a separate flow check would need to be included. Our 00 series stainless steel circulators do come with you can have them with an integral flow check, so they do come with that. All righty, once the system is filled, what activates the pump to run? Oh, one of my favorite questions, and Jesus, I want to address that in just a bit. So let's hang on to that one. I love that question, and that's your control strategy, man. That's the control strategy. So let's see. Steve, yeah, okay, got that, Steve. On the recirc system using the hotline crossover valves, 5 in the use, would the ECM circulator still be set to minimum? Good question, Travis. It would be set to where it needs to be for that system. Remember, it's not cumulative. Think of those hotlink valves as zone valves. All right. Think whatever the flow rate you need is the flow rate you need. So yeah, you would still set it to minimum, but they're like zone valves, right? It's not cumulative head, it's in parallel. So if you think of them like that, hopefully that'll make sense. But yeah, you'd still set it to, you still need to respect the gallons per minute limitation with hotlink valves, which we're going to look at in just a second. All righty, let's take a look at this. Let's go back to our page here, and I want to go up and say no. We're going to start all over again. So I'm just going to hit refresh here. Okay, when you hit refresh, we just generally start over, and there's also a start over button right here for you. So here's what I want to do. I'm going to click on no. There's no hot water recirc system. So this simplifies things a lot. All right, hot water heater type. Let's take a look at our water heater type. Let's take a look at tank. Your piping layout. Crossover valve or crossover circulator with our Genie, and we can look at the Genie in a second as well. But let's use the Hotlink crossover valve. And you want to see a sample piping layout. There it is. And here you can see we use the cold water line as the return for the hot water recirc. And again, 2 weeks ago, Dave went over the operation of the Hotlink Plus E valve. It's a fast-acting snap closed valve, so that when the hot water arrives, we close that valve so we get a minimal amount of warm water really in the cold water line. How much? Well, by the time you turn the cold water faucet on and stick your hands underneath it, it's probably dissipated. All right. We do this because we're not irretrievably stupid. We've worked on this, and we've made sure this valve addresses a lot of the issues that we see with other valves out there. It's fast acting, it's reliable, and it's field serviceable. So want to make sure that we cover that. But let's take a look at this setup, and it just makes life a lot easier here. So again, let's take a look, and let's use type M copper. Okay. Now the piping calculations are easy, right? We only have to do supply. We only have to do supply because we only care about about getting the water to that hotlink valve, and then the hotlink valve closes. So boom, done. So we don't care about we're not recirculating water all the way back to the water heater. We're just circulating water to that last fixture, and that's all the circulator needs to be sized to do. So again, let's take a look at 1 inch, and let's do 20 feet. Something very similar to what we had before. 3/4 inch, we had I think it was 75 feet. All right, and then the 1/2 inch was, I think, 30 feet, if I'm not mistaken. So 30 feet. All right. So pressure drop calculation. Pressure drop is calculated twice the feet at crossovers will be used for the cold side return. So this is easy. The valve itself, the hotlink valve itself, has a flow rate built into it of 0.33 GPM. So 0.33 GPM is it. 0.33 GPM is it. Okay. The head loss is 0.41. So minimal head loss, minimal head loss. So 0.29 feet per second is our total pressure drop is built at 0.29 feet of head, rather 0.29 feet ahead. Valves and fittings, another 0.12. Is there a mixing valve? Let's say yes. At a CV of 1.8, we're looking at 0.08 additional feet ahead. So it's just itty bitty. So 0.3 GPM at about a half a foot ahead. All right. Now, high efficiency pumps, connection types. Let's just look at all for now. And then we hit search. And it's going to give us some choices. Now, if we take a look at the Hotlink Plus E, all right, this is the Hotlink Plus E. This is the kit with the smart plug and the crossover valve. If we look down here, well, look at that minimum. Again, minimum speed. It's just with the Hotlink valve, as Travis asked earlier, with the Hotlink valve, you're limited at 0.33. So you just set this thing to as low as it'll go. Will I have a flow rate of more than 0.33? Yeah, I will. In fact, I'll probably have a flow rate, if I were to calculate this out, about a half a gallon a minute. All right, that's going to be my flow rate. The valve's only going to allow 0.33 through anyway, so it doesn't really matter. And that's kind of where we're at. So what does that mean for us? Well, that means that we have a total volume of 6.6 GPM or 6.6 gallons, but let's cut that in half because really we're talking about just the supply line to we're only worried about the water to that last fixture, so 3.3 gallons. We at 5 minutes on, okay, at 5 minutes on at that flow rate, if that valve is open, we're going to need to have that thing run a couple of times, a couple of cycles before we get that hot water all the way to that final or that last fixture. All right, so it's going to take a couple of cycles, 5 minutes on, 10 minutes off, 5 minutes on, 10 minutes off. In this case, making sure we insulate our hot water pipes will be very critical. All right, so 5 minutes on, 10 minutes off, 5 minutes on, 10 minutes off is where we're at now. It's going to take a couple of cycles to get our hot water line all set up. So if we look at that, okay, we're fine there. Now, if we were to look at even if we looked at other circulators, it really wouldn't matter much because we're still at that 0.33 GPM limit. So I don't know if that was helpful for you or not, but that's kind of where we're at with that crossover valve. And again, if you don't have a hot water recirc line and you don't have the ability to install one, this is your next best. It's your next best solution to make that work for you. Now, if there's another way to look at this, that might be a kind of a large setup. So let's take a look at a smaller house just to see where we're at. So again, tank type, crossover valve, type M. We're gonna do PEX here. Let's do some PEX tubing. And let's say it's simply a smaller structure. So I've got maybe 10 feet of 1 inch, and let's say I have 50 feet of ½ inch or 50 feet of 3/4 inch. Oh, sorry, 50 feet of 3/4 inch. And let's say we have 30 feet of ½ inch. Now, again, you see the head and everything else is very, very low. Let's add the mixing valve. We're still at about a foot ahead here. All right, we're still at about a foot ahead. Let's do a search. And you can see at this point, we're at about a gallon and a total volume of water of about 3 gallons a minute. We're worried about half of that, which is a gallon and a half. Now our 5 minute on, 10 minute off, by the first cycle, we've got this thing primed and ready to go. Whereas in that larger house, it might take 2 cycles to get it primed and ready to go. So again, the value of insulating the pipe, the value of understanding how many gallons you have in that, gallons of water you have in that piping system, and how we're going to work with that. Again, that's going to be the important thing. We want to make sure we get that hot water, that last fixture, in a timely manner, but in a timer type of system, time is on our side. Now, I want to go back to a couple of questions. Uh, uh, one came from Jesus about how do we tell the pump to run. This goes back to, again, Dave talked about this 2 weeks ago. The smart plug, there's a lot of ways to enable a system. The most common, unfortunately, is to plug it in and let it run. But that continuous circulation we talked about, that becomes a problem because that's one of the contributing factors to erosion. So let's take that off the table. That's simply not an option. Can we put in a timer? We certainly can. We sell circulators with timers on them that you can simply set the dip switches and tell it when to come on, when to turn off, etc. The challenge with timers is twofold. Number one, setting them up. Okay, who does it? I've heard contractors say, well, we set it up for our customer. Well, how do you know what their schedule is? Well, we just put it on in the morning and the afternoon and that's it. Or we ask them, which is good enough. A lot of other contractors just give the homeowner the instruction to say, you know your schedule, you set it up, which is inviting trouble because those things aren't that intuitive to set up. So having them set up appropriately to run when you need them to run is always a challenge. What happens generally in that respect is they are either set up to run all the time or they just abandon it and say the hell with it. All right. The other challenge, if the timer is set up properly, is that no one goes back to reprogram them, and when we have a switch from daylight savings to standard time, and nobody goes back to reprogram them in case there's a power outage. So there's a challenge with timers. They're simple, they're easy. Hey, and if you say I want this pump to run from 6 a.m. to 8 a.m. every day, you can do that, and that takes care of that. When you have a timer, when you have time on your side, the size of the pump doesn't really matter in terms of being too small. So we said we might have to wait, go through a couple of cycles with the smart plug to get that hot water line primed. In this case, it doesn't matter. That pump's going to run for 2 hours nonstop. Okay, so there's an advantage there. Again, the disadvantage is who sets them up and who goes back and reprograms them in the case of a power outage or a time change. Some pumps are run continuously, but with an aquastat or on a timer with an aquastat. Now, that's not a bad way to go, timer and an aquastat. The aquastat is on the return line, and simply the timer enables the pump. The aquastat turns the pump off if the hot water, if it's a full recirc line system. The aquastat will turn the pump off when the hot water reaches the point where the aquastat is. Now, most commonly, that aquastat is installed back in the mechanical room on the return line because that's the easiest place to put it. So when the hot water gets back to the mechanical room, we shut the pump off. We don't need it to turn on. It'll re-enable the pump if the water temperature drops. That's terrific. The better place for that aquastat is at the last fixture, but that's the most inconvenient place for it. But it is the best place for it because we don't care what the water temperature is in the recirc line. So that's another way to turn the pump on and off. So it could be a plug-in and we just shut it off when the water temperature drops. Not a great way to go. Timer, shut the pump off with the aquastat when the water temperature gets to where we need it to be. That's better. All right. Lastly is the smart plug. And what the smart plug does is it can run in two ways. It can run on what we call the pulse mode, which means 24/7, it's 5 minutes on, 10 minutes off, 5 minutes on, 10 minutes off, 5 minutes on, 10 minutes off. So it runs basically 20 minutes every hour. Takes care of that continuous circulation thing. But the pump's running maybe when we don't need it to. So it's a question. Do we want to does the homeowner expect to have hot water at every tap instantaneously, 24/7, day or night? Don't give me any excuses. Pulse mode it is, right? Or do we have a situation now with people working at home? Is hot water usage all over the place? I mean, we don't have a set time when we take a shower or do this other stuff. Then maybe pulse mode would be a good idea then. The other mode is what we call the learning mode. And the learning mode basically learns your hot water usage patterns and continuously relearns and readjusts your system. So for example, I get up at 6 a.m. and take a shower. Smart plug's going to remember 6 a.m. John got up and took a shower. All right. So what it's going to do, and that's on a Monday. Okay. Tuesday, he got up at 7 a.m. and took a shower. Okay. Monday, 6 a.m. Tuesday, 7 a.m. So what it's going to do the following week is Monday, it's going to start pulsing that 5 on, 10 off, 5 on, 10 off at 5 a.m. Gives me a 2-hour window from 5 to 7 on Monday in case I get up a little early, in case I get up a little later, or in case there's a time change. Okay, in case there's a time change. So I have that time built in for those 2 cycles in that other example to make sure I get that hot water line primed. Now the following day, Tuesday, it remembers I got up at 7, so at 6 a.m. it's going to start cycling. At 8 a.m. it's going to shut off. And it's going to constantly learn and relearn and relearn and relearn. If there's a power outage, it simply goes back into its learning mode. It'll pulse for a week and relearn your schedule. All right. If there's a time change, we have that 2-hour window built in. So whether we go ahead or back, it's going to understand the time change. Additionally, in a vacation, it has an automatic vacation mode. If it does not sense a hot water event, meaning an increase in temperature, sustained use, and then a drop, if it doesn't sense an event for, I think it's 36 hours, might be 72 hours, it basically says, you know what? Nobody home. I'm going into vacation mode. I'm going to run for a couple minutes maybe every once a week until somebody gets back. And then once somebody gets back and turns on a hot water fixture, we start the learning mode all over again. So those are different ways to enable the circulator in a standard domestic hot water application. So I hope that answers your question, Jesus. And these are the different ways we have to enable the system. Now, a lot more questions. Let's get to them here. Let's make this a little bit bigger. All right, let's go. Can I do that? Yes, I can. Here we go. All right, good stuff. Okay, so do we need a check valve? I think we answered that one. How do we activate the pump? Let's see. On a recirc system using the Hoslink crossover valves, the circulation to be set at minimum. We answered that one. Let's see. On a system without a return line, shouldn't this tool consider elevation changes between the circulator and the last fixture to determine head? No. Good question. No, because what we've created here, Jesus, is a closed loop system. Remember, circulator, not a pump. It's a circulator. So I don't have to lift the water up. I have a closed loop, and in a closed loop, what goes up must come down. So that's just basic circulator 101 sizing. So I don't need to lift the water up. I've got the same amount of water coming back down the other side as a counterbalance. Think Ferris wheel and you got it. Okay. So good question, but no, we don't. It does elevation changes, lift does not apply when sizing a circulator for hydronic heating or sizing a circulator for domestic hot water recirculation, because again, it's not a pump, it is a circulator, and it's just creating that pressure differential to get flow going through the system. Okay, so very good. So the cold water line is the hot water recirc line when the circulator's on. Yes, it is. That's exactly right. Now, I just stepped on my dog. So yeah, the question obviously, and I hope we addressed it earlier, but I'll address it again, is, well, that's dumb because you're going to get hot water in the cold water line. No, we're not, because of the operation of the hot link valve. When the hot water arrives at that valve, at that last fixture, it snaps closed almost instantaneously. So we will not have any more passage of hot water, of any water from that hot water line to the cold water line. And understand how this works. It's not like the water starts out cool and gets progressively hotter as it goes through the piping system. It's cold or tepid at that point. When the pump comes on, we're evacuating that hot water line of cold or tepid water. By the time the hot water is coming in basically a slug, all right? So when the hot water reaches that valve in a slug, that's what turns the thing off. So there's very, very little, minimal, maybe that much, either warm or warmish water that gets through that valve. So yeah, we're using the cold water line in that application as the return line, but because the hot link valve does its job, it closes that valve once the hot water arrives at the system, and we don't flood the cold water line with hot water, because that would be silly. Do we deadhead the pump then at that point? That's another question people have. Do we deadhead the pump? Sure do. Yep, we sure do. We do deadhead the pump for however long. If we're on that 5-minute on, 10-minute off cycle, are we deadheading the pump? Absolutely. Is it bad? Not at all. The pump is running at a minimal speed anyway, number one. And number two, deadheading is one of those things in a closed loop hydronic system with a really, really big pump. You don't want to do it. With a little itty bitty pump, if you deadhead that pump for 10 minutes, is that going to hurt the pump? Not one bit. Not one bit. Been tested, not a problem. Okay, I think we just answered your question. Where does the circulator suck water from? First, the circulators don't suck water; they recirculate. It's different. It doesn't suck anything. It just recirculates. What it's doing is it's deadheading. It's simply not moving any water at all through that loop. So it's pressurized and everything. It's just simply spinning and not moving any water. It's called deadheading. We don't necessarily. It's not a goal, but if we're deadheading a teeny weeny little pump for 10 minutes or so, or actually what's 5 minutes on, 10 minutes off. So the worst case scenario, we're going to run that pump. We're going to deadhead that pump. In the absolute worst case, we're going to deadhead that pump for 4 minutes and 59 seconds, let's say. That's the worst case scenario. It's fine. It's fine. Does Takeo make a circulator with a 0.33 GPM? I don't know of anybody who does, George. I don't think anybody does. We do not. Obviously, no one does. We can't go slower than minimum, and in this case, we'd have to set it at minimum speed. But the thing that's going to control the flow is going to be that valve. So yeah, is the pump going a little faster? Are we over pumping? We are, but we have that. It's like putting that valve on, putting that hot link crossover valve, George, is like putting a circuit setter on the system, is really what it's doing. Consider that a circuit setter. So even though the pump's running at its minimum speed, the flow is going to be 3.33 GPM because that's all that valve will allow. So cool. Excellent, gang. Excellent. A lot of great questions. A lot of really good questions. I do appreciate all this. Just a couple things to finish up with here, and let me just get this thing up and running here. Where are you? There we go. All right. Just a couple things, just some of our DHW circulators and their energy ratings in terms of efficiency, our ECM circulators and their energy ratings. We have 3 stainless steel models here for small residential applications. The 007E, which is 1 setting. The 0015E3, which has 3 settings, 5-foot ahead constant pressure, 10-foot ahead constant pressure, and full speed, fixed speed. Again, in terms of oversizing, both of these are really good candidates for oversizing. The 0018E, I think we've shown this to you many times before. It has an app on your phone, and you have the ability to dial down to the exact flow rate that you want. So if you want 1.6 GPM, we have the ability using our app to set this thing up at 1.6 GPM. That's what makes the 0018E so cool. You have the ability to simply dial it in using the app to the exact speed that you're looking for. And then of course the 006E3. Now these are all of the ECM small wet rotor ECM circulators on the market. Our entire portfolio is far and away the most efficient. We're a good 6 to 10% more electrically efficient than anybody else in the market. In fact, the highest rating that you can get is a 188. We had 5 pumps that were able to earn a rating of 187 or 188. The only other pump in that neighborhood was made by Armstrong. No one else cracked the 180 barrier. That's how electrically efficient our circulators are. The 006E3 is not at that level, but it's a smaller circulator, and it is rated between 162 and 174. But of any domestic hot water specific circulator on the market, that actually has the highest efficiency ratings from the Hydraulic Institute. And if you want to look this stuff up yourself, you certainly can. er.pumps.org. That's the Hydraulic Institute's listing of all circulators, both large circulators for commercial applications, heating and domestic, as well as small wet rotor circulators for residential applications, for domestic hot water and for heating. Full listing by manufacturer and the independent third-party efficiency ratings for those circulators. So this is not saying that this is the Hydraulics Institute, an independent third-party industry organization that's been around since what, 1917, I think. But it's their rating scale, their ratings protocol, their ratings procedure, and we actually rated very well. So you can look those up for yourself on er.pumps.org. All righty, cool. Excellent, folks. Thank you so much for the gift of your time. I really do appreciate it. So again, open it up for whatever questions you may have. The official webinar is over, and I do appreciate your time. So you certainly can take your leave, but I'll stay on as long as you folks want. If you have questions, I've got about another half hour, 45 minutes open before I got to do anything else. So please to stay on and answer questions for as long as you folks like. And it can be on domestic hot water recirculation, or it can be on anything you want. All right. This is again, one of my favorite parts of the whole presentation process is just question and answer. So if you have any questions, shout them out. Thank you, Carrie. Appreciate the kind words. We do so much enjoy offering these presentations for you and doing webinars. I will tell you, TACO After Dark will return in September. We decided to take the summer off just because we are working on our you saw that System M air to water heat pump that we showed that was on the front page of our website. We are working diligently on training our manufacturers reps and our own folks on that. So we have a lot of work to do on that, and that has taken up most of our summer. So we are working hard on that. So we took the summer off for TACO After Dark. We will start up again in September, and it's going to be fun. Some new stuff in there as well. A lot of the basics stay the same, but we're going to throw some other interesting things in there for you as well. So good. John Shore asked a question. I'm trying to select a 10 gallon per minute circulator with 14 feet ahead and getting no results for both high efficiencies and standard efficiencies using the app. Okay, probably because we're not dealing with for 10 gallons per minute at 14 feet ahead. Yeah, you won't see. We try to stay within that app is designed for the residential size circulators. I would think 10 gallons a minute, 14 feet ahead, you're going to be looking at a 0026E or 0034E would be the circulators to look for high efficiency. And you won't find them in that app because that app is designed for residential applications, little bitty circulators. We've been working on a commercial app for a while. I'm not sure where that process is, to be honest with you. So if you're looking for something more commercial, the app's not going to be of much help to you. But if you know the flow and head, then we can then just check. I would look at the 0026E, 0034E as possibilities. I think those would work for you. There's a question, where the main trunk is split into two unequal lengths, can a single circulator be used where both legs have an end return? Boy, that's like, that's the same thing in hydronics, you know. Ideally, what you would want to do, if you can, is to keep those lengths as equal as possible. That would give you automatic balancing. Otherwise, the circuit setter is probably going to be your solution here, where you would want to make sure that the flow through both is the same. So you'd have to put two circuit setters on and adjust them till you get both get the same flow. I think that's maybe where you'd want to go with that one, CE, if that answers your question. You can use a single circulator, but you've got to balance the flow. Otherwise, the short loop's going to get all the flow, right? The long loop's going to go, hey, what's going on here? I got nothing. The short loop's going to get the flow, and that's the same in any kind of hydronic system too. So yeah, circuit setter would be your friend here. Cool, very good, good question. All right, what else we got here, folks? Cool, yeah, John's commercial application. So yeah, I think, you know, if you look at the 26E and 34E, you'll definitely find something in there that will work for you. They're both available in stainless steel flanged. So I hope that works for you. All righty, well, I can sit here and talk all afternoon, but I'd much rather answer your questions. If you guys are cool with questions, then we can say so long. But I'm trying to think of what else do we have here that's available that I can share with you. Again, our System M heat pump, air to water heat pump is a very exciting initiative for us that you're going to see entering the market in October for whole house heating and cooling and domestic hot water creation. It has the ability to make domestic hot water as well. If you're involved in net zero housing, certified passive housing, any low energy construction, you're going to find a really good option here with System M. And what makes the System M so unique is that it's going to we have not only the outdoor unit, which is a real high quality German engineered outdoor unit that is made for us by our our partner in Germany called Dimplex, one of the world's leaders in heat pump technology. They're taking care of the outdoor unit. We're building the indoor unit, which is we call it a hydro box that has everything you need in it, virtually everything you need. Buffer tank, all the electronics, all the pumps, everything is there in the box except your system pump. You will need a system pump, but there's 2 circulators built in. You'll need a third, but everything's built in, fully integrated, variable speed circulator control for your circulators, variable speed compressor, variable speed fan. All right, everything's variable speed, and it's all managed by a central control system to get everything to work together. You're not putting together mismatched components. It's all designed to work together for maximum efficiency and maximum performance. So we're really excited about that. Hopefully, the goal here is it's going to the appliance approach will cut your installation time in half. So it usually takes, if you usually allow 4.5, 5 days to do a heat pump job, now you can get it done in 2.5 days, and life is good. So yeah, I can't wait for it either, Pat. I can't wait for it either. Alrighty, well, I'm not seeing any more questions pop in, so I think I'm going to say thank you, and I do appreciate the gift of your time, folks. Always a pleasure to spend this time with you. And again, you will be getting you will be receiving an email tomorrow with you can download your certificate of attendance, as well as a link to the recording. So if you really enjoyed this and you can't wait to listen to it again, you're going to have the option to do that. So that'd be exciting. So very good, folks. Hey, thank you so much. Really do appreciate it. And hope everybody's staying cool out there. It's been a hot couple weeks. So I hope everybody's staying cool out there and having a great summer. And we will see you soon. Take care, everybody. Bye-bye.